And will you speak first or should I?
I will.
Okay.
Okay. I think I can now.
Yes.
Yes. Okay. Okay. Good morning, everybody. Today, I'm proud to welcome you to this breakout session. First of all, I would like to thank all the speakers that agreed to share their thoughts on this topic and this important topic. I'm Margherita Moreno, researcher in battery advanced material in ENEA. It's the second biggest Italian national research organization. I'm also technical technical expert in the ETIP Batteries Europe Secretariat. And within this role, I was appointed as a factotum assistant in the task force of digitalization. Okay, today we will talk about, maybe we can go on. Okay, thank you. Today we will talk about the digitalization and its role along all along the battery value chain, and also so the key role that digitalization has in the decarbonization process. And so digital technologies and batteries are very big ecosystem and very active ecosystem. And today we will discuss the implication of their interface or the intersection, let's say better. Now I will leave the floor to Cami.Lam. She will present us an overview of how digitalization is a prerequisite to develop a green value chain. Cami is the head of European Public Affairs and Regulation at Cybergrid, and also the co-chair in the Batteries Europe Digitalization Task Force, and she's currently working on to demonstrate cross-border interoperability with 7 national pilots using Cybergrid Flexibility Management Platform. So Cami, please, the floor is yours.
Great. Thank you for that introduction, Margarita. And it's been a pleasure working with you on the task force, by the way. As Margarita mentioned, I am one of the co-chairs of the Batteries Europe Digitalization Task Force, and I am also a member of Working Group 6 on the Batteries Europe platform for stationary storage. Digitalization was recognized as a cross-cutting issue within Batteries Europe across all 6 working groups, and therefore a special task force was formed to address the topic. We all recognize the enormous potential of the battery sector. McKinsey has estimated that overall battery demand is expected to reach around 2,300 gigawatt hours by 2030. But with that growth comes a real need to sharpen our focus on sustainability of that value chain. We see digitization as one of the means to really achieving a green, sustainable battery value chain as it creates a more efficient and interconnected sector. And today I'll discuss what that looks like and what we need to consider to get there. Next slide, please. So one of the things that I'll discuss is the Digitalization Task Force's position paper. This will include an overview of the digitalization across the value chain, use cases, and our vision for a common digital marketplace for the European battery market. And then I'll also discuss the importance of interoperability. This was not a primary focus of the Digitalization Task Force, but definitely was recognized as an issue in some of the other working groups, including the one on stationary storage. Next slide, please. So the digitization across the battery value chain. When you think about digitalization within the battery sector, you might typically think of an EV connecting to a charging station and a platform, and the platform you use to make that happen. However, digitalization covers far more than that. Some of the emerging battery innovations, such as machine learning algorithms, digital twins, battery passports, and platforms for battery goods and services, these are not all used in one silo of the value chain. Digitalization can be found throughout all cycles of the battery value chain. And so here you see a modified comprehensive value chain displayed here on how digitization can really be embedded throughout the whole process. And I would like to take just a second to credit Fraunhofer for this image. They worked really hard on this, and they came up with a nice comprehensive product here. It includes a mix of values, processes, and different levels of the digital layers. Just kind of going across the top, the discovery row here, this represents more of a low TRL, but seeing the use of AI-supported tools and modeling and digital simulations. Going into the next one, the R&D cycle, this is still representing relatively low TRLs with more of an emphasis on the development rather than the research, which tees things up for the next cycle, which is the production cycle. In the production cycle, this is where you would use things like digital twins and optimizing to improve the efficiency of various processes. The next one you would see is the maintenance cycle. This comes out of the production cycle and just includes the digitization of maintenance services across the value chain. The next one is the usage cycle, which will produce data. And this is really where you would see the consumer come into play and the digital services that are closer to the consumer, and not just the consumer end user, but really we're talking about the wide array of stakeholders, such as network providers, auto manufacturers, energy communities, etc. And then finally, the end of life cycle. This is where we analyze if a battery is capable of working in a second life situation, or if it's better to perhaps recycle it. Things to consider would be what raw materials are in the battery, what charging cycle did my battery see, were things sustainably sourced? These are the things that we would analyze at this stage. And all of these things are really big values to bring to the battery, and that we need to really need to integrate at all levels. And then I will just focus on now your attention. If I can focus your attention on the bottom row there, the gray boxes towards the bottom. Here you'll note the type of expertise and education that is needed to bring each cycle forward. I was talking to one of my other co-chairs, Henning from Fraunhofer, and he was saying, you'll note, in order to transform the value chain to a digital one, we really need the competence to support this. And it's not just scientists, but really the whole workforce needs to be scaled up to, as I said, move each of these cycles forward. And then through the middle, you'll see the middle layer for system integration and semantics. This is really to highlight the need to combine the software and hardware tools that we need and create a central highway to connect everything through APIs so everything can speak the same language. So to kind of conclude this slide, by advancing the digitalization of the battery value chain, these cycles will be more efficient, interconnected, and ultimately help to meet the needs of governments, businesses, and consumers. Moreover, this leads to a stronger, more transparent battery market with accountability and sustainability really embedded in every step of the way. Next slide, please. So the other thing that the task force worked on was to define use cases in terms of battery energy storage systems and the flexibility that will be needed. Next slide, please. Thanks. In addition to what you see here, the Digitization Task Force, for each use case, I identified levels of innovativeness, time to market, research and innovation investment required, the value and impact of each use case, and links to the market and supply chain. So I won't go through everything here in detail, but I'll just describe what each use case sort of covers. For the first one, automated materials discovery, this really aims to increase the pace of development of new battery chemistries. It will fundamentally change the way new materials will be discovered and also change cell production and testing. The next one, the Green Battery Passport and Digital Referential. This is a popular one on everybody's minds these days, it seems. This use case would see a transparent and fraud-proof traceability of the full life cycle from raw materials all the way to end of life. And of course, we recommend the development of such a passport should be in line with the concepts described in Article 65 of the proposed battery regulations. The next one, advanced methods for SOX. What we mean here is state of charge, state of health, state of energy, and anything I've missed there. The advanced sensing at the cell level to analyze individual wear and critical failure states. That's what this would advance, which would allow for mitigation measures on the cell or pack level. The next one, hybridization and multi-use. This one is, I think, a bit self-explanatory. It would really help bring the flexibility. Yes, thank you. Help bring the flexibility of EVs to the grid and fully exploit the full potential of virtual power plants and demand-side flexibility, and also realize the full extent of those services and asset monetization. The next one, accurate data sheet generator. This one would see the full exploitation of large data sets from the lab, the field, and from simulations, which would allow for the automated generation of application-specific data sheets, and estimations of state of health would be expected as well. Digitalization of the battery cell production. This would entail data-driven processes based on generic system architectures of production processes. This would also be used for the setup of holistic digital twins utilizing relevant production data. And finally, the battery ecosystem marketplace platform for management services and supplies. This is a bit of a vision for a platform to provide different market players with well-cataloged access to information on battery systems and complementing services. And this leads me to my next topic. Next slide, please. A vision for a common European marketplace. The task force is proposing a lighthouse project to make things easier for consumers by creating a one-stop shop access to battery information and products that they need. This is really just a vision. Our position paper does not prescribe details on how this would be implemented necessarily, so it's really just a vision. The task force considers it important to address consumers' needs for battery-related information, supplies, and services in a really in a user-friendly manner. This type of platform would address the needs of both EVs and stationary applications and inform consumers about how to optimize their battery storage resources by making it easy for consumers and uh, or rather stakeholders, homeowners, EV owners, large industrial customers. You can see here, we do list the full breadth of all the stakeholders here uh, to really engage in the battery use and services, which would likely increase demand and therefore growth in this sector of the European economy. We think this would also serve to strengthen the EU battery market and overall circular economy. Products in this battery market will, of course, comply with European battery regulation, so that would also be part of it as well. The vision for such a digital marketplace would really be underpinned with European-based products and services, and thereby raising the prominence and increasing the competitiveness of the European battery sector. Next slide, please. And finally, I'll talk about the importance of interoperability. Interoperability, I see it as really it's interoperability between devices, IT systems, and various platforms is really key to a key underlying component to digitalization. Next slide, please. Without interoperability, implementation costs will be higher, time to market will be longer, and system benefits for EU electricity and battery systems will be delayed. But what would interoperability do? It would create devices that have true plug-and-play capabilities for the Internet of Things and seamless connections throughout the battery value chain, and thus leading to the provision of innovative services and thus scaling. But realizing interoperability throughout the battery value chain is no easy task. I'm I'm part of the Interconnect, the the Interconnect Horizon project, and it is no easy task. The one of the true priorities of the project is interoperability, and yeah, it's quite a feat. So, but really, more and more stakeholders are realizing its importance and supporting efforts to achieve interoperability in various ways. So, some ways to reach interoperability. There are a lot of technical issues to tackle in this field. So, continuing research and innovation efforts is really a first step. There are many standards that have been developed across various sectors of the economy. Aligning these standards that apply within the battery sector, and I would also include demand side flexibility, is really key. Not necessarily developing new standards, but aligning existing ones is what I would also stress here. Interoperability will not happen on its own. Strong support is required at the EU level through the facilitation of cooperative efforts. So, a really strong support at that level is key as well. And finally, I would also suggest that the creation of a dedicated battery interoperability alliance type of group would help foster the development, adoption, and compliance of battery data interoperability. And with that, I believe I am I don't know where I am on time, but that is the end of my presentation. Thank you very much for your time and attention, and I really look forward to hearing what the panelists have to say. Thank you.
Thank you, Kami. Thank you very much. It was a very interesting and comprehensive overview. I might be biased because we work on this on this this document for many months.
Yeah.
But I think it gives a very comprehensive picture of what really signify the digitalize the battery value chain. So thank you very much. So now we will start the first panel discussion on Horizon Europe partnership and digital innovation along the value chain. But only after I will briefly introduce our panelists. So women first, Lian Kemp is the founder and the CEO of Everledger. And Lian is a member of the World Economic Forum Global Blockchain Business Council and co-chair. What? There is a strange. Okay, co-chair of the World Trade Board's Sustainable Trade Action Group. And in our ledger, she is addressing the real world challenges through. It's me or sorry. Okay, I was saying that. Okay. Yeah, that's Lian with Everledger is addressing the challenges, the real world challenges driving transparency and trust along the global supply chain using emerging technology. And then we have Toma Transnik, sorry for my pronunciation. He is a full professor of energy engineering and head of the Laboratory of Internal Combustion Engines and Electromobility at the University of Ljubljana. He researches focus on multi-scale modeling of batteries and other technologies, and also an expert on vehicle powertrain related simulation and modeling tools. He is also a member of EU Partnership 2.0 and BAT4EU. And Meyer Chebo is the founder of C Technologies and is the chair of the ETIP Batteries Europe Digitalization Task Force and co-chair of the ETIP's net, so the Smart Grid ETIP on Digital Energy Group. He also was the co-founder of the ETIPSnet. He has more than 30 years of digital experience applied to industry, and so he has a very 360 degrees profile. Thorsten Freund leads the program to develop the Global Battery Alliance Battery Passport, and so he has been delegated to GBA from BASF since July 2020, and in BASF his work was focused on developing chemistry-driven sustainable solution. For instance, the GBA battery passport ecosystem will be designed to become the key instrument for fostering a sustainable and circular battery economy. So now I think we can start. And I would like to start a simple question for each of you. So why digitalization? And you can bring to us your thoughts on it. Maybe just one of the two expert according to your experience. And so I don't know if who wants to start? Maher, please. No, you are mute, Maher. We cannot hear you. So maybe while Maher, you are trying to solve this problem, can we ask the other panelists to answer the question? Why digitalization? Of course, related to batteries.
Maybe then I can start. Do you hear me well?
Thank you. Yeah, I can.
Yeah, there should be some echo, but yes. Good morning to everyone. Thank you, Margarita, for the introduction. And I think anyway, Kemi set a very good stage, so it's hard to top it. But maybe to start with some different words, it's when we look back, so why digitalization and computers were invented. So they were invented to solve problems that are beyond human capability. And I think this is still very much valid. And let's say I will try to maybe a bit summarize what was shown with my own words. So what we want to do is we want to approach engineering limits, and certainly we want to also approach the first time right. And so if we look to it, certainly it's kind of a vision if someone could really look at the periodic system and design its own perfect material. Then use a virtual tool and produce this material virtual world. And we are now with the material, then assembling the cells, then let's say putting the cells in packs, stacks, putting this in vehicles, seeing all the interaction, and yes, at the same time monitoring and seeing if the simpler models, which will later be digital twin, provide sufficient information. And with this, at the end, we simultaneously, while doing this, could be assessing our life cycle impact. So which materials we use, what is the environmental damage that we are doing, or let's say, what is the consumption of energy and material that we use also in this value chain, and later on also how we recycle. And certainly, if we can do this very fast, very efficiently, with common databases, with interoperable tools, we certainly fully support this first-time right approach, and we are kind of complying with all the guidelines. But yes, I think we will talk a bit more, not to be too long in this opening. I think there is quite a long way until we will have everything supported with really credible and interoperable digital tools.
Yeah, I might just chime in. I think succinctly, global trade relies on goods and services, but value chains rely on data and digitization. And I think we're all aspiring to create value in various parts of the supply chain. And to be able to do that is simply a connected digital environment.
So if I might jump in, I see that the change happening here is unprecedented in the past, let's say, century. We are moving towards a completely new value chain, transforming from a carbon-energized value chain towards an electrically powered value chain. And with this, new challenges comes from the raw material fields down to the technology implementation for the users. And to make all this transparent, and see how we can jointly solve problems which may arise from one stage, but will implement a much later stage in the value chain. There's digitization, the key tool to transport the information, to provide analytical tools to really understand what's happening in these value chains.
Okay. Can you hear me now?
Nonetheless, we need to keep in mind that we have to drive this change in the real world, and the digitization must support mankind in achieving those missions.
Thank you, Thorsten. So Meyer, you can jump in.
Sorry, the mic had a problem. I don't know from which side. So the digitalization is really an enabler. So all the digital technologies are here to support creating new services, new value-added services, new scenarios, new use cases that bring on top of the existing hardware the intelligence where we can measure really the value. So if I take an example of the electrical networks, if you don't have intelligence on the electrical networks, they cannot connect a large number of renewables. they cannot connect a large number of smart meters, for example, where we have to read the data of the consumption of the customers every 15 minutes. Same for the batteries. An electrical mobile battery in an electrical vehicle cannot deliver the performance which is required, at what time we need to store the energy, how much we need to store energy, how we need to discharge, for example, from the battery when we are driving, to fit with the speed and the usage and the conditions and so on. The electrical vehicles will not be efficient. And same for the stationary batteries. The digitalization brings the flexibility. If you get in the game what the electricity system providers are delivering, the renewables which is being self-generated, for example, on the buildings, and you have a battery in the middle and you don't have digitalization, this cannot work. So it's as simple as that. It's like the body, and then the body without a brain, for example, can maybe move, can eat, and so on, but it cannot do 90% of what we are doing today without a brain.
Thank you. It's really a good metaphor. So now I feel like Europe is participating on a very difficult race, let's say. So I was wondering how the digital process or the digitalization can enhance the competitiveness of Europe, of the European batteries. What do you think? Maybe Mar, or yeah.
Just to continue, the other continents have been good in the e-commerce business. So you have most of the leading companies in the e-commerce are either Americans or Asians. However, in Europe, we have fantastic engineers, and this is where the digitalization, for example, can be successful. I worked for like 20 years for SAP, which is a large European digital company. And then I worked also for an American company like General Electric Digital. And even the Americans, they were looking at the engineers in Europe, either in Italy or Spain or in France and Germany, to succeed in the digitalization story. So we are capable in Europe to have a digital platform that becomes a leading digital platform on the market, with the engineers, with the good advance we have done in the telecommunications as well, the 5G. Some of the European telecom operators are leading in the 5G, and also in the IoT technologies, and then in data science. You don't need just pure techies to do the digitalization. If you have a pure techies, it is not going to work. You need double competencies. And all the education we get in Europe as engineers provide the double competencies. You are an aeronautic engineer, plus we give you also skills and competencies in IT and digitalization. You are an energy engineer, plus a competency in the digital and so on. That double competency can help building data models, data scientist models, and these are the ones that will help giving really the fantastic intelligence and building a European platform that could be competing with the rest of the world.
Thank you. Thomas, would you like to add something to Thomas?
Yeah, thank you for a question. So anyway, Mahed said it all, or nearly, but maybe just also a slightly different angle from this. I would say it's without a doubt that digitalization will bring huge benefits. But now it's just a question how big these benefits will be and who would be at the leading position. And yes, I fully agree that everyone is in the race, but I think Europe, with its great potential, also sufficient amount of critical mass of, let's say, very good engineers and scientists on one side, but on the other hand side, also with strong industrial basis, but on top of it, with very good organizations in HE partnership, has a capability in this century really to build these interoperable platforms. And I think this is really what can make a difference, not a single digital tools, but this really seamless interoperability of models, flow of data, flow of credible data, and this really speeds up the process. And the one who will be leading this will have shorter turnaround cycles and could bring or boost its competitiveness.
Thank you. So, as anyone what would you like to add something, or we can go further?
Maybe we should not only see it as a competitiveness issue, rather than building stable supply chains. We just have experienced the lack of microchips for slowing down the automotive industry, and we should think about how digitalization can support stability in the local supply chains, supporting a European battery network which is stable against disruptions of international trade, and helping us to build a sustainable network with a circular economy.
Yeah, good point. Yeah. So maybe we can go to the next question. I prepared for you, but because I was thinking we have, for example, Thomas. He is representing the Horizon Europe partnership, and I'm thinking how the partnership can foster the digital innovation along the value chain. So do you think there are gaps to be covered funding R&I activities within the partnership? Of course, the question is for you, Thomas, but also for the others.
Yeah. You know, I think as long as we will push the boundaries of science and technology, there will always be gaps. And I think gaps should not be seen as something that is, let's say, on one side, a deficiency of something. But I think identifying a gap just means that we see a vision where we can be better. And I think that this meaning we have solved this and now we move over with other things, it's not always appropriate. And I think we should always build on what was currently said. Certainly there is a huge demand to build on interoperability. And yes, certainly it's a supply chain, is sourcing of raw materials, is recycling, is entire life cycle of the product. And there, I would certainly dare to say that there are a lot of gaps before we have such a platform or interoperability. But also when we will build it, it will not be finished forever. Because we will go ahead, we will create new science, and certainly it will be easier to build on already existing knowledge, but we will always have to push the boundaries. And the same goes also for models on particular scales. So we will continuously enhance them. But yes, now if we see what was happening now, currently, let's say, I think more than ever, we are interacting along the value chain between different sectors, and also, let's say, globally, how we interconnect also in the markets. And certainly all these tools were not developed to be interoperable. So this I would see as a big gap. And also LCA tools, how we can analyze this. Also Europe has envisioned this. But also we will have to push boundaries, as I will not try to go too much in detail because most probably the panel 2 will address this in this particular scales and how we solve this. So let's say if I now just briefly go back to 2.0, certainly 2.0 focuses on vehicles, and there it's a main focus and competencies how these devices operate in vehicles. But in order to understand this, it's very good to know what happens before. So which materials are used, what are, let's say, the critical challenges with these materials, let's say how to operate batteries, that they will last longer, that they will be safer, and also how to operate them to mitigate degradation, how to ensure their longer lifetime, because this has a huge lifetime impact. And then certainly this fits into the broad perspective of a battery passport all of a sudden. So yes, I think there are quite some gaps, but I think there are also with initiatives as EU partnerships, they are properly addressed and we are progressing, but this process will be long and at the end everlasting with some moderate effort.
I saw that running out of time, so maybe I would like to touch other important topics. So
for example, the sustainability, how the digitalization can enhance the sustainability of the battery value chain. And of course, I'm thinking of the battery passport. And the first person I would like to intervene is Torsten.
Yeah.
Thank you.
Thank you for attributing this competence to me. So if we're talking about a battery passport, we have to define what we are talking about here. And this definition of the terms is really one core aspect. There will be many aspects in sustainability, starting from the technical parameters like greenhouse gas footprint, like the water use along the supply chain, or social aspects like is child labor excluded in the value chain of a battery passport, and are workers treated appropriately. The value chain is not a value chain in a linear sense, rather than a global network, and will provide information about the real world in the form of data, which have to travel throughout the world into this one battery, which will be produced in a single plant somewhere here in Europe. So in order to do so, first of all, you need to specify which data you want to see. And the second thing is that these data throughout the value chain on a specific issue are standardized, so that we are really comparing apples with apples and oranges with oranges. And there are intelligent networks, and Leanne may comment on that much better than I do, how these data are transported without being muted, that we have accurate data at the point of the battery. And the prerequisite will be that people who are affected come together and agree on common language, how to measure sustainability, which data are provided. And once we have this transparency and agreement, that can drive change by a proper analytics. And this needs to combine the digitalization, transporting the data, with the intelligence to analyze the data, derive information, and drive change.
Thank you. You raise a very good point, and you bring in Leanne, and I would like to hear what she think about the
sustainability is such a broad sector of the market. It's everything from greenhouse gas emissions to human rights legislation. But look, I will say one thing: Everledger works at both extreme ends of the supply chain and the value chain. We've been commanded by the Australian government to utilise the Everledger platform for a national traceability program on critical minerals. Australia is the largest producer of lithium and will be for an eternity of time. Collected together with our trade partners in Canada, we know that the significant amount of critical minerals that are clean and green will come from Australia and Canada in the world. Both countries are pursuing aggressively environments upon which national traceability programs and ethical certification can be brought to the forefront of trade. And so I've been working in provenance for the better part of my eternity. In fact, I think I've tracked everything from cows to kangaroos in Australia, and Everledger's most famed for our work in diamond traceability. And being in COP26 over the last month, it's very clear to me that parts of Scope 1 greenhouse gas emissions are likely to be easily achieved and will be achieved quite rapidly. But 70% of the problem exists in the world with Scope 3. And we cannot achieve Scope 3 reporting if it is not for traceability and provenance being at the forefront of that Lego building block. And I think that the efforts that we're affording in conversations like this, where governments seem to be awakening, and of course, trade partnerships around the world, that's going to be a critical component. So whilst it's the hardest problem to solve, it certainly has the greatest prize for the planet.
Thank you. So it's really a huge topic, and we commonly we don't think about the data, and we trust the data, or we don't trust not with not much thinking about it. But it's a very let's say hot topic also these days, because people don't trust data for example, for the pandemic, and people trust it. So it's I don't know. I'm a bit worried maybe for the future because as you were saying, we need something all over the world to take care of this issue. So would you like to comment further, or maybe we are out of time? Oh.
Technologies that are available today are the technologies that can enable the connectedness of a supply chain. It's the willing participants in an industry where we can align towards value and value creation. And it sounds very easy to describe. Certainly we've achieved that in the diamond and color gemstone industry, but because it's hyper consolidated, it's 500 years in the making, and there's already global constructs like the United Nations that came together in 15 years ago, that there is a mechanism upon which the participants in that chain can easily work together. We need to, however, identify that parts of the work that we're doing has to be identified as a pre-competitive space. There's no sense in competing against the saving of our sustainability footprint. We should be easily saying this is a pre-competitive space, and for that very reason there should be the right alignment of values in the reason why we're going down this pathway.
Thank you. So I think it's now time to start the Q&A session. I saw already one question coming from the audience, so maybe we can start it. And I ask also Cami to switch the camera on, because the first question is for her. Cami, are you there?
Yeah. I was also going to, if Maher wanted to take it too, that would be fine as well. But I think that one of the things that I'm sorry,
I don't know if everyone's. Do we have to read the question, or everyone read it?
I do see the question. The question is, there are already companies creating marketplaces for sections for the end-to-end battery market. How do we avoid fragmentation of the marketplace so that it remains open, user-friendly, and we capitalize on the synergies between market sections? I think, I mean, yes, of course, there's going to be already some things happening in the private sector, but I think part of our vision could partially be driven by an EU platform of private industry coming together to create a common platform. But that is just one idea, so that we don't have this fragmentation that you could potentially see in the marketplace. I don't know, Maher, do you want to add on to that?
Yeah, I don't think we need absolutely to have one marketplace. There will be a number of marketplaces that are connected. If you go to e-commerce marketplaces, they are connected to each other. So you can go to Amazon. Amazon can send you to another marketplace where you could buy something else as well. Here, what has been presented by Cami, and then on which we worked at the task force digitalization of batteries, is a proposal that includes the complexity which has to be done, where we need to integrate different stakeholder systems like electricity networks, like energy production and renewables and other equipment vendors, integrate that complexity of their systems to make it easier for a marketplace where you have one-stop shop, where you have users to have access to all they require. So that marketplace would include also the right regulations, that we don't have a wild marketplace. You might have others, for example, that will be created here and there. We might connect to them, but here what we are talking about is a marketplace which includes the right regulations, consider also what should be done, not done, the privacy, for example, taking care of that as well, that it's not really a wild marketplace. But at the end, we are not saying there should be a monopoly. monopolistic behavior for only one thing. In the market, there is plenty of marketplaces that exist, and some of them are connected to each other through partnerships and others not.
Thank you.
Certainly, this will be a thing which evolves over time, and we should not think that we just can sit down and plan it and build it, rather than define the right rules of this marketplace, that it is interoperable, open, and can be expanded over time, that we allow some kind of evolution of these marketplaces, rather than set this one place for the time being. This will be really a very interesting journey, and digitization in the right way to be interoperable and transparent will pave the way for having an effective marketplace, even driving sustainability forward.
From the user perspective, they will not know what's behind it anyway. From the user perspective is a link to internet, like they go to Google or they go to an Amazon. And behind that, there will be the complexity, the links between different systems, between data centers, and so on. From the user perspective, even the term maybe marketplace, they don't care about it. It's just a link on the internet where they can find their services.
Yeah, it's a very good vision, I think, this one. And I see that there are no other questions, but I would like to comment that there is a very nice recap of our talk right now, because Nicolas Bonfoy said, thinking sustainable and acting digitally. It's a very nice recap for what we are saying now, and I think I will make a t-shirt with this with this sentence. But if there aren't any other question, I don't know, maybe we can go to the next panel discussion, or I will ask the panelists if they would like to provide.
If I would like to comment on the sustainability side, a lot of companies use sustainability as a PR topic, marketing topic. And now it is not anymore a marketing or PR topic. The CEOs and the top managements of companies do not get their bonus if they are not acting sustainable. So that means they have to put in place all the programs showing that they will be carbon free by 2025, 2030, that they will make also their customers to become carbon neutral, to reduce their footprint. It's a must-have, not anymore just a marketing tool. And for that, they are looking after putting all the digital systems that they could do it as quick as possible. Without the digitalization, it would take them years, and not sure it will happen.
Yeah, thank you. You're bringing hope. Thank you. And I would like to ask, so we have a few minutes more, and maybe if the panelists would like to say one final comment, you are free to join, to intervene.
If I may answer directly to Maher, if I look into the industry surroundings, this change, what you're saying, is happening. Industry really is working on processes which are reducing CO2 footprint. They're working on processes for responsible sourcing, and this message is received and action is taking place already. Now, I think that the perception now throughout society and throughout economy is clear, and now it's just the time, use digitization and do it.
Yes. Now, this is why a lot of companies, the transformation, you know, if you're an enterprise, you care today post-COVID about how to survive, how to keep your finance, your profit and loss correct. In the same time, you have to transform yourself, because the way of working becomes hybrid, remote working, some physical working. And so they have to think about all these social things as well, and the employment conditions. And they have to think about making most of their processes remote operations as well. So how you can make a factory continue to work when you have a COVID, for example, is by putting digital processes, is by supervising to a maximum what happens in a factory. And at the same time, they have to reduce their carbon footprint. So all these changes are happening at the same time. And today, sustainability should be put in place as an opportunity as well to keep their finance good, to keep them profitable, and not as a constraint where they were looking at that as a cost weight. They say, I'm going to spend money, I would reduce my profitability because I'm reaching out sustainability. No, this is today more an opportunity, but it has to be done in the right way. Why they are thinking post-COVID, they are thinking the digitalization to become an opportunity and not a weight or a cost.
Yeah, absolutely. So these multiple challenges need to be addressed at the same time. Of course, digitization has a lot of potential to help that. Nonetheless, these digital systems have to be invented and implemented. So they are not available today, and this will take us a journey over the next couple of years or even decades.
Absolutely.
And we need to be very humble, not to be over-ambitious, rather than realistic, that we keep our pace, that we keep confident, and we will do it in the end.
Mm-hmm. Absolutely.
Maybe
yeah.
Sorry, please go on.
No, I mean, and this is why, when companies are looking for a new top management or new CEOs, they are not looking anymore at the pure industrial CEO, like a telecom CEO or automotive CEO. They are looking for the ones who have in their experience some sustainability, some digital, a lot of digital profile, to say, yes, these guys are going to disrupt the company and they are going to bring something new to transform my industrial company into a digital industrial company.
Yeah. And maybe with this, just since one of the aims of this, let's say, discussion was also to, let's say, bring forward the gaps and the needs. And maybe we can start with some praise. I think EU very recently very much identified digitalization as being important, and also comparing to, let's say, a decade ago, where this modeling, simulation, digitalization calls were not that often. I think now we really have a lot of them. And I think, again, I'm a bit repeating myself, but the combination of the human capabilities that we have, the good industry, and let's say funding instruments and systems should bring us forward. So let's say I would try to say that maybe EU even further, or EC even further, looks in this direction and really systematically supports digitalization to keep us at the forefront, because I think this is, as was said, the main mean how we can increase, or one of the main means how we can increase our competitiveness.
Yeah, and we have a compelling example in front of us, which is the vaccination for the COVID. They would have never ever discovered the vaccine for the COVID in a few months. In principle, it takes years, 10 years, for example, if they did not use all the data analytics behind. Okay, that helped them really to get very quick here.
Yeah. Yeah, I was also thinking while you were talking, but yeah, we are now running out of time. But you were talking about new opportunities, new jobs. Maybe there is a comment from Lian on this, because from an enterprise point of view, you can tell us, or maybe the audience, there are young researcher or young people that maybe to comment and say them for the future.
Yeah, sure. Look, I mean, we've seen already the largest FANG companies, whether it be Facebook, Amazon, Google, appoint their CTOs as CEOs. And I think that generalized trend in that direction is now also being adopted with other companies around the world. So for me, it's all about nerds. We need more of them. Let's get them on the keyboards and put them in the boardrooms, and problem solved.
Thank you. So now I think it's time to start the second panel. So I will thank again all the panelists for the first panel, for the very live and interesting discussion. So thank you. And
Thank
now, thank you. Now, the second panel is, let's say, more research dedicated, let's say, and we would like to dig into the impact of the digitalization on accelerating R&D on batteries, material, and cells. So I will again the panelists and always women first. So Elisabete Ayerbe Olano. She is a team leader in modeling and postmortem in the material for energy unit of CIDETEC in Spain, in San Sebastian. And she is coordinating the activities related to multiphysics and data-driven models, as well as the parameterization and postmortem analysis on lithium-ion and advanced lithium-ion batteries. And she also leads the research area of manufacturability in the Battery 2030 Plus initiative. And we have, sorry, can you switch the slides, the next slide? I saw already still the panel, the first panel, or maybe it's my, no. So, sorry for the interruption. I was going to introduce Professor Thijs Beggen, and he is the head of the section for atomic scale material modeling and at the TU, Technical University of Denmark. He is currently working on the development of autonomous methodologies for accelerating material discovery and innovation processes. And in this field, he is coordinating the Battery Interface Genome Material Acceleration Platform project, the Big Mac project that is under the umbrella of the Battery 2030 Plus initiative. Mark Kodrak is an engineer and is from the and is also emeritus scientist at Natural Research Canada's CanMet Materials Laboratory. And he is the Canadian representative and international co-lead of the Material for Energy collaboration platform for mission innovation, Innovation Challenge 6, Material for Energy. This international challenge deals with the development of material acceleration platform, the MAPS. Autonomous and also the autonomous of or self-driving laboratories for clean energy material development. And last but not least, Stefano Saguatti. He is the executive manager in Mans, Italy, with more than 35 years of experience in lithium cell battery manufacturing. And also in R&I for automation process and technologies. With Mans, he developed industrial production equipment for lithium battery cell assembly for consumer, industrial, and automotive application. Okay, so welcome you all. And now I would like to open the discussion with this quote from the very first day of the Battery Innovation Days on Tuesday. The Vice President, Maros Tekovic, stated that the challenge now is to go from made in Europe to invent in Europe. And so I would like you to comment how can digitalization help in this? And also, what are the main drivers in your research work in applying the digitalization tools to your work? So I would like you all to comment. Thank you. You can start the first maybe women first again, but as you wish.
Okay, I can take this. So, yeah, taking the first phase, I would just say that somehow the digitalization facilitate or the acceleration of the invention. So somehow you can make it more it's accelerating or facilitating this transition. So we have several examples at Digitech in which we, I hope you can hear me properly. Sorry, I didn't ask the question, but yeah. So at Digitech, there were like two drivers that moved or gave us to start in the modeling activities like a decade ago. So the first driver was that there's a continuous need in improving cell performance, such as, for instance, we are searching for higher energy density materials and cells, or power density. Even we want to enhance durability of the cells. So there was a continuous need in this aspect, and we thought that modeling could contribute accelerating these achievements in a way that you can get more understanding on what is going on in that field. So you can identify in advanced methods these limitations so that you can avoid even in the cell design phase or cell manufacturing. Now that I'm talking about the manufacturing phase, we at SWEDE have a pilot line in which we develop and manufacture prototype cells, large cells. So we have the facility to control the expected outcomes, modifying certain parameters in the manufacturing, but we wanted to perform in an automatic way or facilitating this optimization. So we realized at that point that data mining, data driving method could give us this knowledge and information to reduce the time to optimization. So I would summarize that, yeah, there are two main drivers here, is that this continuous needs in improvement, and improvement can be on cell performance or even the sustainability, because if you have a control on the manufacturing phase, you can, for instance, reduce the scrap in this phase, and which is in line with the sustainability requirements and the capabilities of modifying or making more flexible the manufacturing plant through these digital twins could accelerate again this process.
Can you hear me?
Yep.
Yeah. Good morning, Margherita. Thank you for the introduction. Innovation and invention are not coming alone. You need to have innovation. You need to have specifically in batteries, communication between all the value chain. So it's not something that is coming per se. And what we are doing what we did in Europe, creating the implementation plan that is coming from research up to industrial deployment, like the tool, the instrument like IPCI, all interconnected and all approaching in a holistic way all over the value chain are really are giving us really the possibility to believe that we can move from battery made in Europe to really inventing in Europe. And we all know, and I can express it in my long experience, that like with a short sentence, in God we trust, everybody else bring data. We need data to support the innovation, and when we are presenting our innovative project or solution to our board, we need always to bring data, because data are really the instruments that are allowing us to get authorization to proceed with the new and innovative project. Data, when you have a new idea, can only come from simulation or speculation, but it's very difficult to bring data based on DOE when you have just in mind some new innovation. So in this perspective, I am quite confident that a further development of digitalization all over the value chain, therefore communicating with in a very holistic way, will allow us to become really leading even in terms of innovation in Europe.
I think if I pick up from Stefano, I would say that the digital materials discovery is for sure a way that we can shorten the discovery cycle for developing new battery chemistries. And I think if we look at it, it is potentially a transformative way of sort of leapfrogging the traditional sequential and Edisonian battery development process that will allow us to develop sustainable ultra-high performance batteries in Europe. And this is really a cornerstone in Battery 2030 Plus and in the Big Map project that I'm fortunate enough to coordinate, where Eli and Tomas and others are also involved, that if we can develop a digital infrastructure, we can really reinvent the way we invent batteries. And I think that's probably the core of what we're trying to do. We want to develop an infrastructure that allows us to utilize data from all parts of the battery discovery value chain at the point when that data is most valuable and most needed. So instead of doing a sequential, siloed type of discovery process, we need to develop an infrastructure that allows us to exchange data across the different traditionally siloed domains in battery discovery. And creating a common language and data management plans are essential for this. So I see that as a key component in bringing Europe to the forefront here, creating this shared data infrastructure. Really is a way forward.
Yes, and I waited a bit. I wanted Thijs to go first because he's in charge of Big Map Battery 2030. I'm involved at the higher level to deploy maps, the self-driving labs more globally. And of course, there's countries that are more involved. The European countries are heavily involved in the activity. Thijs really is highlighting the fact that we have three technologies that we have in front of us today: artificial intelligence, robotics, and high performance computing, that we never had the excellent resources to apply to these problems. And I'm going to step back and say we have to push the boundaries of technology. We heard that from Tomas earlier in the prior session. And I have to say that we are really paying attention to that phrase by linking synthesis, characterization, and computation in a single platform that loops 24/7, runs continuously if you can feed it enough information, but you generate massive amounts of data. And the AI is there to work on that. So digitalization of the solution here is critical.
Yeah, and maybe continuing this discussion, what do you think, Mark and Thijs, mostly? What are the main obstacle or bottleneck in this paradigm shifting in the discovery of a new material?
Well, if I start on that one, you can say data is one thing, but interpretable data or fair data is another thing. And when you're trying to do that in one domain, it's a challenge. When you're trying to do that in multiple domains, spanning simulations, experiments, testing, ultimately also end user data, right? That is a massive challenge that we're trying to undertake. So create common languages or ontologies that allows the different domains to speak together and allows us to exchange data seamlessly, as was also pointed out by the first panel. I think that really is a huge technological bottleneck, and couple that with standards that allows us to do a fair comparison between different types of battery materials, cell designs, and so forth. those are massive challenges that that have to be done on an international scale, maybe even a global scale.
Yeah, and to follow up, Thijs, I think it's really important. You talk about trusted data, but one of the things that I worry about is verified trusted data. And when we link computation to synthesis, we are able in a rapid turnaround to be able to say that the predictions that were coming from computation are actually verified in science. And these computational platforms, or I should say these materials development platforms, go through a huge experimental space. So finding nuggets, good combinations of materials that give us the right answer, and then go back to computation to learn why, and then find improvements on it. That's the link with these self-driving laboratories. So I think trusted data from computation, trusted data from experimentation on a rapid basis. That's what's going to get us there.
Okay, good. So you touch also the other topic I was going to ask you, because the data are very have a central role, and also Thijs said that we need maybe to work all together, not only in Europe, because this is very, very important. We don't have to have different infrastructure in different countries, because it will be a belly or of data. So maybe we need an effort worldwide. What do you think?
I would say at least on the standardization and also on the ontology, because we will have many different data archives, repositories who will need to create APIs that allows us to bridge those domains. But we are working together also with US partners and Canadian partners also to standardize some of the ways that we actually describe data, and in particular, I would say metadata, because that is really a challenge. How do you do that in a way that allows you to do this fair comparison of data, but also to assign fidelity or value to given data points, right? You need to have the metadata in some quantifiable form as well.
Good, yeah, right. So because we don't have too much time, because I will keep talking about this maybe more and more, but I would like also to touch the cell topic and also the manufacturing. So, and I was wondering if you think, maybe Elisabeth and Stefano, if the digital innovation applies to battery manufacturing could close the gap between the research and industrial deployment, maybe could help in closing the gap. Please. What do you think?
Okay, maybe I can answer that from our perspective. Obviously, I think anything on the digital aspects might facilitate to reduce this gap between the research and the industry, although we might have like different needs in a way that, for instance, in our research company, we have our pilot line, and what we want to have a complete understanding of the impact of process parameters of the outcomes. So we are always searching for certain targets of the cell, and we need to control in a proper way how these parameters are impacting. So digital tools, including sensors in the manufacturing chain, data acquisition, and can give this information as you might detect certain defects in place, and you can somehow stop the plant in a way that you reduce the scrap, for instance. But we basically rely on digital tools to understand the impact of certain parameters on the outcome, while as far as understand industrialization or at the industrial phase, they are searching for robust manufacturing facilities, but searching for obviously for high cell performance, but also taking care on the sustainability, CO2 footprint, or even cost effective or lead time. But anyway, what I do believe is that these digital twins built upon this research pilot plan could be scalable and could help at the industrial phase to later have this more decision-making control on the real industrial scale pilot line.
I fully agree with Elizabeth. First of all, more than close the gap, I should say to reduce the gap, because a gap is what is keeping us alive. It means that we have a challenge and we need gaps, otherwise we become no fun. So, but it's clear that what we have to do is really to develop digital method based on reliable digital twins. We need to develop them and pre-validate them on a pilot research line in order to predict with more accuracy the performance and the impact on giga-scale production line. In this respect, initiatives like LiPlanet are crucial for the validation of digital tools on battery. How to do it? For sure, a mix of model-based and data-driven solution within the integrated infrastructure, the factory seems the optimal, for us, the optimal path. Models are computationally expensive and very time consuming and complex to be developed, and they might be very specific for any application. Data-driven solution, on the contrary, can learn from experimental data and furthermore better capture non-linear phenomena. Both require extensive data to support this development. Therefore, a mix is required between model and data-driven system. Just both worlds have to be explored together.
Yeah. Thank you. I think it's too short, this panel session, because I have plenty of questions, and it's really interesting, but 7 minutes to the end. And so I would like to touch lastly the fact that in the next future, that new job opportunities that will arise thanks also to the digitalization of the battery value chain. And I'm worried a bit because do you think that there are missing skills for these new job opportunities? And how do you suggest to take this into account in developing new academic curricula, or also to have a specialized for workforce for these new job opportunities? Just we need short comments, unfortunately, because the time is very short.
Digitalization digitalization is really a cross-cutting activity in all scientific education program. We need to have even scientists and engineers and technologists. All of them have to be grounded to understand how modeling can be developed. So we need really to when we go in the real environment to have people that are able to have a complete education.
Yeah, being a university professor, maybe I can add that the combination of having good electrochemistry understanding, good understanding of digital tools and data-driven methods, that is something that we're really striving to develop a curricula to support this, because we can see there's a huge demand for that combined expertise in industry. Fortunately, there's also a high interest among the students. So fingers crossed.
Yeah.
Yeah, and maybe if I can just comment as well. Really, one of the things that we realized with the autonomous or self-driving labs is that we have a multidisciplinary team that's coming together, and the material scientists learn digital knowledge and digital approaches. Then you move to the technologists, the engineers that are designing the robotic systems. They're learning about materials. We're teaching them multidisciplinary skills. And it's through these laboratories that we'll produce the PhDs and the PDFs that really go to industry and can change the manufacturing fabric, the way that we approach things with those broad skills. I'll leave it there.
Yeah, perfect. So the keywords, it's hybridize also the skills and the curricula. Yes. Okay. Good. And so we will able to understand both of the words, the digital world and the material and engineering can talk together, because I understand when you have a group with multidisciplinary people in it, it's difficult to bring them talking in the same language. So this is a good point. Thank you. And I don't know if Elisabetta, you want to just a take-home message for people to this, but.
Yeah, I completely agree with the statements of the speakers. Yes, we needed this strong interaction with material science, as it was already mentioned, computer science, electrochemical science, but also process engineering, mechanical engineering, and electrical engineering. So, but yeah, this is my contribution.
Yeah. Okay. Thank you very much. Thank you all the panelists. For the short discussion, but we have this slot of time, and so before we close the session, yeah, of course, I would like to remind. I don't know if the switch the slide. Okay, yes. I would like to remind you that the next two breakout sessions starting at 11, one on job. Of course, we touched this, so you can maybe interesting to continue on this concept, on this discussion. The next one on job creation, and the other one will be also very interesting, a new emerging market and application. And I would like also to remind that the presentation and the recording are already available on the website, or so they told me. I hope that it's correct. And again, I would like to thank you all of you, all the speakers that were in this session, and thank you very much for the high quality and the interesting topic that were touched along the discussion. And I thank you very much also the audience and for the kind attention. And so now I think it's, yeah, we have 1 minute and 37 seconds left. But I think that we can say goodbye to everyone and just finish the session.
Thank you.
Thank you, Margarita.
Thank you, Margarita.
Thank you, Margarita. Thank you, everyone. Bye.
Thank you.
Bye.